In this tutorial, I want to talk about a property of concurrent programs called liveness. Okay, there are a bunch of problems associated with concurrent applications, and it's important to understand that this property called liveness and a certain set of problems which affect the liveness of your application. You can say this application or this piece of code has liveness or it doesn't have liveness. So what is liveness? Liveness indicates if a program is in a general state of activity. Is it doing something in general? You often have this experience of some application being stuck. Okay, some application is hanged or something like that. What does stuck or hanged mean? Basically means that it's not ending, right? It hasn't errored out, it hasn't crashed or anything like that, but it isn't doing anything either. It's on hold, okay? It's not making progress. So liveness is a property of an application that indicates that this is something that is generally making progress, okay? It requires a system to make progress. And there's this Wikipedia definition for liveness, which says that something good will eventually occur, okay? It's like you're running a program, you want it to do something eventually, even if it's stuck at a certain point of time, okay? Even if at this particular moment it's not doing anything, something good will eventually occur, which by the way is what my school teachers told me when I was a kid after looking at my report cards. But anyway, so this is what liveness is, right? It's going to do something eventually, even if it's stuck at a certain point of time, it is going to make progress, all right? So you typically think of a program execution like, okay, you start a program, you start an application, start a process, it executes, and then it completes successfully or it errors out, right? This is the ideal state. It's either making progress or it says, I'm done. But there is this fourth possibility, which is that it hangs, and this is what affects liveness. If the program is just doing these three things, it's said to be live or lively, okay? If this is, it's hanging, then it's said to not have liveness. So what causes liveness issues? What causes liveness issues? There are a bunch of things that can cause it, and it doesn't really apply to concurrent programming necessarily, okay? So for example, you can write an infinite loop. There can be a bug in your code. You have a while true, and then you don't have any condition where the while loop exits. What do you have? You have an infinite loop. And with that infinite loop, is the program making progress? Well, it might be making progress if the infinite loop is what it needs to do, like some kind of a daemon which needs to constantly keep doing something. Well, that could technically do it. But if you have an infinite loop which is not doing anything, but it's stuck for something else, well, then that is a liveness issue. Okay, so this is liveness without even talking about concurrency. But when you are talking about concurrency, there are three specific issues that can affect the liveness of your application. The first thing is something called as deadlock. Second is something called live lock, and the third thing is something called starvation. I'm going to explain what these three issues are and how they affect the liveness of an application when dealing with concurrency. So what is deadlock? Deadlock is basically where you have at least two threads which are waiting for other threads, but then the other thread is also waiting for something else, which results in kind of like this mutual waiting, and this is what causes a deadlock, right? There are multiple threads waiting for other threads, and the dependency is somehow circular. So let's say thread A is waiting for thread B, and thread B is waiting for thread A. Well, then you have a deadlock. A common example that I can give for deadlock in a real world situation is the no you hang up first problem, okay? So imagine like a young couple in a real world, a new couple having a phone conversation. The conversation is, romantic in nature, and after a while it's time to hang up, and neither of them wants to hang up first. If they're the only person in the line, then they have no problem hanging up. So they've had their phone conversation, they need to hang up, and they keep saying, no, you hang up first, okay? So there's nothing stopping them from hanging up except for the other person, right? Here are two, essentially threads, and each thread is stopping the other person from ending the thread, from ending the conversation, right? So this is a classic case of a deadlock in a real world. Here is an example of a deadlock in Java, okay? So I have two synchronized blocks over here. It's a nested synchronized blocks. Yes, synchronized blocks can be nested. So when a thread is trying to execute this, what does it need to do? It needs to first get this lock, which is the first synchronized block, and then it has to get this monitor lock, which is the second synchronized block, and only then can it execute this piece of code which is inside it. Okay, so let's assume that this is the only piece of code that is synchronized by these object references. Then you don't have a problem, right? This is perfectly fine. But let's say there is another piece of code here where the lock is in a different order. Okay, so let's say you have this first external synchronized block is with object reference 2, which is inside here, and then what is over here is what was outside over here. Okay, so it's in a different order. Okay, so there is this specific order of execution which causes a problem of a deadlock over here, right? So let's say you have two threads, thread A, thread B. Thread A is trying to execute this thing, and thread B is trying to execute this thing. And let's say they kind of kick off at the same time. There are two cores which are executing these two threads. They kind of happen at the same time. Thread A acquires the first lock to object ref 1, okay? And thread B acquires the first lock to object ref 2. And now thread A says, okay, I got this guy. Let me get this guy. It's trying to acquire a lock to object ref 2, but it cannot because thread B has already got it. And now thread B is saying, okay, I want to acquire object ref 1. And it cannot because thread A has got it. So what happens now? Well, both these threads are stuck. This cannot release because this needs this lock, and this cannot release because this needs this lock. So they're going to be waiting indefinitely. All right. So this is a problem, and this is what's referred to as a deadlock, right? The application is essentially locked, and since it's not making any progress, it's essentially dead. Okay, it's like it's stuck. It's not doing anything. It's just indefinitely waiting. There are other variants of this, of course, like the circular invocation of synchronized methods, right? So you have synchronized methods. It may not be synchronized blocks, but then there is one synchronized method which is calling something else, A calling B, B calling C, and C calling A. Let's assume they're all synchronized. Now, if all of them happen to be on the same object reference, like all methods of the same class, then you don't have a problem because the lock would have already been acquired by that thread. But let's assume they're different objects, and now we have a circular invocation and you run into a problem. There is another variant where two threads are invoking join on each other, right? So let's say you have thread 1, thread 2. Thread 1 does thread 2.join, and thread 2 does thread 1.join. What happens there? Well, the result is two threads potentially waiting forever, right? Because the join requires that the other thread be complete, but the other thread won't be complete because that is waiting for a join on this guy, right? So it never ends. So you potentially have threads waiting forever, right? So this is deadlock. This is first off the liveness issue. Now what happens when an application hits a deadlock? It doesn't end, doesn't throw an error, but it doesn't make any progress either. It's just stuck, right? It's hanging. So this is a liveness problem. So your application has a liveness problem if it encounters a deadlock. So there is a second type of liveness problem, which is something called live lock. Okay, I call it the smarter deadlock. This is not an official term, but I tend to call it that because when you try to be smart and try to avoid a deadlock, you end up sometimes having a live lock issue. So you might think, well, what is live lock? A deadlock makes sense, right? The application has a liveness problem. It's not making any progress, so you can kind of think of it as dead. Well, what does live lock mean? If it's live and it's moving, how can it be a lock? So let's assume that you have a naive solution to a deadlock. We've seen the deadlock problem earlier, right? You want to solve it. So what do? You say, okay, I'm going to try and get lock 1, okay? And then I'm going to try and get lock 2. If lock 2 is not acquired by a certain amount of time, then I'm going to release lock 1, okay? And then I'm going to try again after some time. Seems like a simple solution, right? Simple. You want to avoid the deadlock, right? You have two threads which are trying to acquire two locks. So let's try the first lock and then try the second lock. If I don't get the second lock, I don't want to hold on to the first lock, right? Otherwise, that's what's causing the deadlock problem. So I'm going to try for a little bit, see if I acquire lock 2. If I don't acquire the second lock, I'm just going to release lock 1 as well. And I'm going to retry after a fixed amount of time. What's the problem here? Well, imagine two threads doing the same thing, right? Thread 1 tries to acquire, let's say call it lock A and lock B, right? Thread 1 tries to acquire lock A. Thread 2 tries to acquire lock B. They both get it. And now they're trying to acquire each other locks, all right? So thread 1 is trying to acquire lock 2. Thread 2 is trying to acquire lock 1, and they don't get it. So what do? They both release it. And they wait for some time, and then they try again. Again, the same thing repeats. Thread 1 tries to acquire lock 1, thread 2 tries to acquire lock 2. They get the first lock, they don't get the second lock, wait for some time, release it, and so on and so on and so on, right? They keep doing this, and guess what? They're not essentially dead. They're trying to do something, but then they're still stuck, okay? An example of a live lock, a real-world example of a live lock is two people in each other's way in a corridor. This has happened way too many times for me to admit. Really embarrassing situation where I'm looking at my phone or seeing something else. I encounter somebody in a corridor, and that person also realizes they're in my way, and we both realize it, and then we both step to one direction, right? I step to the left, the other person step to the right, and now we are again in each other's way, and we say, oh, sorry, I'm gonna move, again, I'm gonna move, step to the right, the other person steps to the left, and now I'm again in each other's way, right? So we can keep doing this dance. We can, as humans, realize that this is a live lock situation. At some point of time, one person stops, okay, and the other person moves, and then we have solved the problem. But imagine if both of us stop and stop trying, we still haven't made any progress, and then again we may take the same step, we move, and then we're still in each other's way. This is a very embarrassing situation, but this is a good analogy of live lock. Okay, we are trying to solve the problem, right? Both threads are trying to solve the problem, but even though it seems like we're doing something, we're essentially not doing anything. We're still locked, but it's not completely dead. It's just spending some resources trying to get away from the lock, but still going nowhere, right? So this is a live lock. This is when you have a potential deadlock and you have some steps taken to mitigate the deadlock, and it causes this perpetual corrective action, which doesn't go anywhere. So it's not completely dead, but it's not moving either. It's like all the activity that the application is doing, all these threads are doing, is just to get the lock, and it's going nowhere, right? This is kind of similar to a stalemate in chess, okay? You're playing chess and you have a stalemate. It's not like a checkmate where it's completely locked. It's a stalemate. Nothing moves further, but you're not completely blocked either. The third example, the third problem that causes liveness is something called a starvation. Starvation is when a thread is kind of ready to run, but it's never given a chance. Okay, a real world analogy is a struggling actor. You might have a seriously good talent as an actor or as a sports person, but they never get a chance. The actor never gets to play in a movie. The sports person never gets to play in a game. What you have there is a starvation problem, right? The thread is ready to run, but it's never scheduled by the executor, for example. Threads have priorities, right? Both operating system threads and even the JVM threads. Let's say there is a low priority thread, which is never executed by the processor because it's never scheduled by the executor. And this results in kind of like this indefinite postponement, all right? So this is also another thing which causes liveness issues. So liveness issues with concurrency, we have again 3: deadlock, live lock, and starvation. Now, how do you avoid them, right? The problem is a little tricky. There is no specific Java or JVM feature to avoid these kind of problems. Okay, in fact, you get into these kind of problems because you use the Java/JVM feature for mutual exclusion, right? You use synchronization. Use it incorrectly, well, you have a possible deadlock or a possible live lock. So you don't have any out-of-the-box features to avoid them. It's just about experience and careful usage of locks, okay? There are certain scenarios which are kind of like begging for you to think about when you're coding and make sure you don't get into these issues. Like, for example, if you want to use more than one lock, well, you got to be careful, right? Is there a possibility of something else using that second lock that you want to acquire and depending on you to release that first lock? You got to be very careful about that, right? So there are certain kind of telltale signs of deadlock and live lock that you need to be aware of, and you essentially get that with experience. There's nothing that a video course can teach you to avoid these issues. What a video course can teach you is understanding what these issues are and why they happen, which hopefully this course has.